Time and distance. Section 1. Time and distance. There is another thing too which is quite important, and it's speed. Let's see how these three things are connected to each other. Speed is distance divided by time, and to see this clearly, let's represent time and distance as two axes in Cartesian coordinates. Then speed is the line which indicates the transformation of time to distance and vice versa. Example, if A moves with a speed, let's say 2 meters per second, then what's the distance covered after 2 seconds? It's 4, right? And also, give a little attention to units. You don't want to add apples to oranges. Okay, section 2, problem 1. An aeroplane flies along the four sides of a square at the speeds of 200, 400, 600 and 800 kilometers per hour. Find the average speed of the plane around the field. So an aeroplane flies the same distance x 4 times with speeds being 200, 400, 600 and 800. And we need average speed. Call it y. The obvious temptation would be to average those values like that in arithmetic mean sense. But it's wrong. You could have done that if the time was constant. In here it's distance which is constant, and the average or the mean is harmonic in nature. You will see that for you. You'll see that for yourself. So the time t1, t2, t3, t4 equals total time, and when you convert time into its other counterparts, it will be distance divided by speed. Then after simplifying, you will get average speed to be that. Problem 2. A and B are two stations 390 kilometers apart. A train starts from A at 10 a.m. and travels towards B at 65 kilometers per hour. Another train starts from B at 11 a.m. and travels towards A at 35 kilometers per hour. At what time do they meet? Step 1. Laying out the picture. There are two stations A and B 390 kilometers apart. Right at 10 a.m. a train starts its journey from station A to station B with 65 kilometers per hour speed, and at 11 a.m. another train starts from station B to station A with 35 kilometers per hour speed, and he wants us to say when they meet. Step 2. Find the relation and solve. Let's say they meet x hours after 10 a.m. As we know, the distance that the first train and the second train covers should be 390 at the time when they meet in the middle, then formulating that just gives us the answer. So go on, give it a try. And if you're new to this series, please look in the description. There will be a playlist containing all the videos in this series for you to follow along.